Problem 3. Summation n is equal to 0 to infinity of n cubed x minus 2 raised to the nth over n cubed plus 3. It's a power series where the center is at x equals 2. Looking at that x minus 2, if you set that equal to 0, you get x equals 2. Not geometric, so we're going to use the ratio test. Take the limit as n approaches infinity of the n plus 1 term over the nth term. So every time we see an n, we're going to replace it with n plus 1. So we get n plus 1 quantity cubed, x minus 2 raised to the n plus 1, n plus 1 cubed plus 3 over the original series n cubed x minus 2 to the nth, n cubed plus 3. Not a lot to simplify in this mess, but one thing you can do is reduce the x minus 2 to the n plus 1 over x minus 2 to the nth. Again, there's one extra x minus 2 on top, so that comes out to be an x minus 2 all by its lonesome. And the rest of that algebra, unfortunately, is there to stay. Make it easier on yourself. You really just pay attention to the highest powers. On top, you have n cubed plus 3 and n plus 1 quantity cubed, but the highest power of n you'll ever get on top will be n to the 6th. Likewise, on the bottom, n plus 1 cubed plus 3 times n cubed, if you look at the highest powers, you'll get n to the 6th plus, again, lower powers. This limit, then, is the coefficients of the n to the 6th and top and bottom. You get 1. Which then leads us to the absolute value of just x minus 2. So now we know that if the absolute value of x minus 2 is less than 1, the power series will converge. And if the absolute value of x minus 2 is equal to 1, the ratio test would fail and we don't have any idea whether they converge or not. But if the absolute value of x minus 2 is greater than 1, the power series will diverge and we just need to get rid of that. And I'd like to take a look at the center. The center is at 2. And we're going less than 1 space away or equal to 1 space away and questioning it. So if you think of that 2, you're going to go 1 space to the right, 1 space to the left, and you see that you have divergence past 3 on the right, past 1 towards the negative side on the left, and in between 1 and 3 you have convergence, but again at the endpoints 1 and 3 you don't know what it does. So again, we know that the power series n cubed x minus 2 to the nth over n cubed plus 3 converges between x equals 1 and x equals 3. Now we need to check the endpoints. We'll check x equals 3 first. So we plug 3 in for x and get the summation n cubed, 3 minus 2 to the nth over n cubed plus 3. 3 minus 2 is certainly 1. Get 1 to the nth, which is 1. And we have the summation of n cubed over n cubed plus 3, a new numerical series. So it's going to be an nth term test, seems like the trick. And we have limit as n approaches infinity of n cubed over n cubed plus 3. That's equal to 1. That's not 0. So x equals 3 creates divergence at that endpoint. So again, the power series n cubed x minus 2 to the nth over n cubed plus 3 converges between x equals 1 and x equals 3, but diverges at the endpoint x equals 3. So now we check the other endpoint, which is x equals 1. Plugging in 1 for x, we get the summation n cubed 1 minus 2 raised to the nth over n cubed plus 3. Then you subtract 1 minus 2 to get negative 1. And it creates an alternating series, negative 1 to the nth, n cubed over n cubed plus 3. So of course we can use the alternating series test. First condition, limit as n approaches infinity of n cubed over n cubed plus 1 is equal to 1. That's not 0. So the other endpoint, x equals 1, also diverges. So in conclusion, power series n is equal to 0 to infinity of n cubed x minus 2 to the nth over n cubed plus 1 has a center at x equals 2, has an open interval from 1 to 3, so it does not include the endpoints, and the radius is 1 because you go 1 space to the right of 2 and 1 space to the left of 2.